ಯಾರು ಸಿಸ್ಟಮ್ ಆನ್ ಮಾಡ್ಕೊಂಡು
Sir, Mohammed Belkilfa, sir. Mohammed Belkilfa, sir. Is it audible, sir?
Professor Muhammad Dept.of, is it audible?
Yes.
Okay.
Yes, because I saw that we are not respecting the schedule.
Oh, okay. Sir,
But I have no much time, really, yeah.
pardon? Okay.
Next invited talk will be delivered by Professor Mohammed Belkalifa, sir.
I don't know
I
how we
would like
can
to
do it, yeah.
introduce Professor H.D. Nagaraj, sir, Department of Mathematics, Bangalore University, Bangalore. I request Nagaraj, sir, to introduce Professor Mohammed Belkalifa, sir, and take over the section from here.
I'm very happy to introduce Professor Muhammad Dept.of. He is professor, full professor, the Taiba University, Kingdom of Saudi Arabia. And PhD, got a PhD from Mathematics KU Leuven, Belgium.
ಕರ್ನಾಟಕದ ಹೆಮ್ಮೆಯ ಸಿಎಂ ಮಾತಾಡ್ಬೇಕಾದ್ರೆ ಮರ್ಯಾದೆ ಕೊಡಬೇಕು, ಸೈಲೆಂಟ್ ಆಗಿರ್ಬೇಕು, ಆಟ ಹುಡುಗಾಟ ಆಮೇಲೆ. Please.
Is it clear?
Yes, clear. You are audible.
Just to, yeah. The screen is clear.
Screen, full screen. Can you make it as full screen, sir? Okay.
Just a moment, I will.
ಮೇಲ್ ಲಾಗಿನ್ ಆಗಿದೆ ಯೂಟ್ಯೂಬ್ ಓಪನ್ ಮಾಡಿ. ಒಂದು ನಿಮಿಷ.
Okay.
This is how fast YouTube is with Brave. Notice how there's no pre-roll ads? And here's how you can see how much
nice conference, and I have chance to see again my friends and also my colleagues. And it is nice. How this work is related to for this, there is 2 points. One
ಇಲ್ಲ ವಿಜಯ ವಿಜಯಮೇ ಇಲ್ಲ ಅಲ್ಲ ಇದಕ್ಕೆ ಸಿಸ್ಟಮಿಕ್ ಅಥವಾ ಅಲ್ಲಿ ಸಿಸ್ಟಮೇ ಕೇಳಿದೆ ನೀವು ಹಾಂ
And
ಡೆಟ್ ಮಾನಿಟರಿಂಗ್ ಮಾತ್ರ ಆ ರೀತಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ ಅದು ಬೇರೆ ಯಾವುದಕ್ಕೂ
yes, this is very typically, I take more time for that to explain it because namely we are going to talk about pseudosymmetric and Richard stands and also pseudosymmetric and we need the remaining curvature. So this formula is very, very important for like space form. And there are many references about. There is a book of Blair, where we can get more information about structures in general. Yes, and also Jan O'Connor book and so on. This is this example. This is the first key we can say starting during my stay in Leuven and working with Richard Dash and Paul Stralen. So. Why this example is important? Because this is exactly the structure, three-dimensional structure. And at that time, it was that color structure not needed to be pseudo, because if it's pseudo, it's always symmetric. I will give the definition later. So, but between time, Orshak gave an example of four-dimension color, which is a pseudo, all right. So this is important as a key because why I'm saying about this is the first key of starting the structure and pseudo symmetry in the Richard sense. You see that you have two eigenvalues, we are same and the set is different. And also for three-dimensional, if you have all eigenvalues are the same, quickly you say the space form. Right. For the general, give me just here generalized Sasaki space form as Allegre and Criazzo in 2004. So they, instead of this here, these constants, they changed it as functions and and they gave three, which means remaining curvature is depending on three functions f1, f2, and 3. So for this, also we studied we have some results related to the generalized Sasaki space form, and we prove that is an sort of with f1 minus f3, but it's an old work we can say because I'm focusing for the generalized with two structures. Why? Because one is Sasaki space form and one is vector field. So how about if you have two vector fields? So some examples about the structure of generalized space with this for S space form, S structure. So we have here how many? You have S1, sigma S, so we have many, and you have this compatibility, and also you can get all structures as like structure or normality, yes. And this is the sectional curvature of this structure. With two structures here, which we need, because for as a manifold, we talk on the last part. With two structures, you have XC1 and XC2, so we have the least Riemann curvatures depending on how many, 8 functions, right? And the Ricci is given by this formula and the scalar curvature 2, and one remark, thanks to my friend Tripathi, and that he looked at that as a remark, F7 is the same, should be the same, and also from my part and my colleagues, we said we should, that F5 should be the same as 6, and they had talk, during my visit to Sevilla with structure should be like that now. Yes. Yes, so that if you have B generalized S space form, if M is a metric contact, so we have this is conditions. Okay. And these some examples. This is some examples, and let me, because we have no much time, and to go far, there's some examples. Need some discussion with me, so you can send me an email. And this is some examples. And here, this is about the action of the Riemannian curvature. So here, the starting for this definition, 6.1, and the Riemannian curvature is what acting as a derivative on tensor. So, and you have, for example, you have 0k tensor, you have R dot T, which is 0, 2 plus k tensor, and also action of the wedge x, wedge y act as a derivative on tensor T, so you can say QAT for a symmetric tensor. So, and according to take A as a G, which is the Riemannian curvature, so you can get R dot R or R dot S or QGS. And this is the first remark about definition of about pseudo-symmetry in the sense that you have R dot R as a function in direction of with QGR. Yes, where in UR, which is this condition non-zero, which means for R is equal, so we have a space form. First is obvious one, R dot R is 0, is semi-symmetric, which is well-known classification by Zabu work, right? And also for result about Ricci pseudo-symmetric, so we have relation between R dot S and QGS in this USS. And also for Ricci semi-symmetric, yes, we have also the work on Mariozan, Mirzoyan, and another now, which is one key, which is quasi-Einstein, that the Ricci curvature has a atmos 2. Yeah, here is in work dash, Pragmat for 3-dimensional is so if it's quasi-Einstein. So remember the 3-dimensional Sasaki quickly you can get. That is for this reason. So it's very motivating to see the higher dimension. Yes. And this is nice theorem. It's very nicely for 3-dimensional. It's very simple that R dot R is a Q, which is the second value, the third eigenvalue by 2, which is a function dash function. Can say this is dash function. So it's for all 3 zeros, so quickly you can get R dot R examples and so on. Yeah, for this year it was one result, more than 20 almost, that we proved that with dash and Verstrada, every Sasaki space form is solo. And then more than that, the function is 1, the function dash 1. Yes. So as and it's pseudo, so it's Ricci pseudo. For C no 1, so Sasaki space form is not Ricci symmetric, non-semi-symmetric whatsoever now. Yeah, and Sasaki space form is a proper for C no 1. Yes, and the famous example of Sasaki space form with P-section curvature -3 is a proper absolute. It's a very nice example. Yes. Yes, for generalized Sasaki space form 3 functions, we prove that any general Sasaki space form is realistic solo with this function. Okay. Yeah, I think here is for now we're going to see for generalized. I think it's better to go far. Here, for generalized with 2 structures. Yeah, some technical computations. Here, before that, we have a remark, a theorem, that if you have, this is the result, proved with Cady, is if you have generalizer with two structures, which means F1 until F8 functions. So it's not Ricci pseudo-symmetric, cannot be Ricci. That's first, yeah. And here, as corollary, we can note some examples because we have as examples of generalized Sazakian with two structures. Okay. And also, we gave some conditions because we are using some here for the water product. We can give condition that to be a pseudo. And then the work, when it is a Ricci pseudo. I think I have not much time. I think it's better to go to the extrinsic properties. It is for a space form. Just let me. We need this if we have an isomanifold and manifold. So we have this is a Gauss and Baumgarten formula is well known for geometers. And the relation goes and quadratic equations. And one is, if we say parallel to manifold, so we have this as should be zero and assuming parallel. This is we can say extrinsic properties. For S manifold, as I talked before, we are interested to see for this S manifolds with you see here you have 3S with the caddy that this is some examples that this every S manifold space form cannot because cannot be a Ricci pseudo and also not a pseudo, and also is a pseudo if only if S is 1 should be, yes. Now a tensor is a second order tensor is parallel if the connection of B is 0, and how about if you have you are looking to this second order tensor in S manifold. So this is one second order parallel tensor is proportional to the metric. If S is 1 and is a linear combination of 4 if 4S is higher and the metric tensor and 1, 4. Yeah, I think there is a guy from India. He has an error about his work, but I will be in touch with him just to give him some remarks. Another one is now as an application that if you have a hypersurface that C turns to the vector fields and S non-S, so there is no parallel hypersurfaces. And the same here, if you have a hypersurface tangent to the structures, cannot be a parallel. And the final one, there is no semi-parallel tangent to the structures, hypersurfaces in S space form. So, and for particular case, there is no semi-parallel hypersurface in R2n plus S, R2n plus S, such that the homomorphic sectional curvature is minus 3S. So, thank you for your attention. So, I have only 1 or 2 minutes because, as you know, that is a Friday, Player Friday. So, please, if you, okay, I can stop now sharing. And if you have any questions, please, I will be happy to do. Oh, sorry. Yes.
Mathematician.
So I think if you have no, I should leave the session. Okay? You hear me? Yes, Professor Katisha. Yes.
Yes, sir, you are audible, sir.
Yeah, it's okay now. I stop or what? There is any question or because I have not much time. I should go there or Friday prior. Okay. Anyway, thank you very much for this opportunity and good luck for the rest of the program. Okay, thank you very much. Okay, bye-bye. Thanks. I may say hi for my friend Zafar.
How are you? Assalamu alaikum.
Fine, and you? So, as you see, it's extremely difficult to communicate with my colleagues because they are working parallelly sessions. One is online, and the second one is also in the building of the Department of Mathematics.
Okay,
As I said before, for them is a prayer time for us here in KSA. So
yeah, it is Salat al-Jum'ah.
Yeah, absolutely. Yes. Assalamu alaikum. Okay, thank you very much.
I have just finished my Salat al-Jum'ah.
Alhamdulillah. Okay, so send my best regards for the organizers. Assalamu alaikum.
Thank you very much.
Yeah, thanks.
Sir, on behalf of Mathematics Department, Kobe University and Tensor Society, I would like to thank you for a nice presentation
Thank
in
you
the
very
conference.
much.
Okay,
Thank you very
sir.
much. Thank you. Bye-bye. Bye.
Bye.
Thank you, sir.
Next invited talk will be delivered by Professor Zafar Hassan sir and take over the session from here.
Can I introduce? Sir, introduce ಮಾಡ್ಬೋದು.
Good afternoon. It gives me an immense pleasure to introduce Professor Jafar. In fact, he is my very good friend. Nice to see him here. At least online is happening. I'm happy. Otherwise, we would have been together at Shimoga. It's indeed a great pleasure to introduce Jafar sir,